Hugo Bound Anderson here, the host of the data science, ML, and AI podcast, Vanishing Gradients, for a live stream with Vincent Warmerdam. Vincent,
Hi.
g'day. How are you?
Good. So yeah, you're in Australia. I'm definitely sort of in the Netherlands, and the kids awake. We just did the whole morning ritual, and life is good. But we did have to go through a morning ritual, kids
I
and all that.
I can appreciate that. So as Vincent mentioned, everyone, uh, he's in the Netherlands. I'm in Sydney, Australia. So we're at the opposite ends of Tuesday. If you wouldn't mind introducing yourself in the chat and letting us know where you're calling in from, where you're watching from, and what your interest in such things are. Do you work in AI or machine learning or data science? Have you seen some of Vincent's videos? I got to say, I'm so excited to be here today. I do want to say a few things by way of introduction. So Vincent is a senior data professional, machine learning engineer, among many other things at Probabl, which is a relatively recently formed company, which is the exclusive brand operator of Scikit-Learn. Vincent is known for challenging common assumptions and exploring innovative approaches in data science and machine learning, which is one of the many reasons I invited you on here today. But we're here to talk about what an interesting and really moving quickly, accelerating space we work in, but perhaps ways we can rethink what we do in data science, machine learning, and AI. And we're going to talk about a bunch of projects that Vincent works on and make some cool announcements as well, and wrap up with some live coding. Please do ask live demos. Please do ask questions in the chat, and we'll do what we can to feed them into the conversation. Also, the obligatory, if you enjoy such things, please like and subscribe and share with friends as well. But without further ado, I want to jump in and maybe Vincent, I've said a bunch about you, but maybe you can introduce yourself and let us know how we ended up here today.
Okay, well, it was a nice summer in 1988 when I was born in New York, and
I didn't know it was New York. I knew you were
I
born in
was
America though.
I was born in the United States, yes. But like was there for like a few years, like up until I was two. Like there are pictures of me in like Sesame Street, the theme park in New York. Then I definitely moved back to the Netherlands. I did do 2 years of junior high school, one in Boston, one in California. Like in Cupertino, I lived there for a year. Like Steve Jobs, like you learned that years later, was like a block away, kind of, because Cupertino is a small town. Um, did my college and high school in the Netherlands. I did have like 1 year of design engineering as a major before I switched to maths. And I do think that that's kind of relevant because one thing that you do learn when you're doing design engineering is to always check your constraints, like test your assumptions there, and also things like if you're going to be designing a wheelchair, the best way to do that is to actually use a wheelchair for a week and see
I
what's
mean,
wrong with it.
who would have thought?
Yeah, well, I mean, but I noticed there was a stark contrast with the mechanical engineering department because the way that they learn how to build like a wheelchair, and I will say this was like a fun competition. Back in my day, what they would do is they would give them all like motors and stuff, and like who could build the best motorized wheelchair. That was kind of like one of their challenges in a way. And that's a very mechanical way of looking at a wheelchair, and there's merit to that. But that sort of design thinking is something I did always, even though I decided not to go for a career in it, something about that did stick. Like, hey, you've got the theory, that's nice, but in practice, it can definitely still be broken because the UI is bad or whatever. Um, and I guess like that's part of the story and how I got here. Like when I was in college, I definitely studied math, but I had lots of extracurricular activities. I was a bartender at one of the sort of most famous Dutch comedy theaters, and I do like to think that if twice a week you're watching a comedy theater thing in the Netherlands, that does have an effect to your presentation skills as well. Um, so I guess like that's my background, and if you then look at what I'm doing in data science today, like that background helps paint the picture. I think that's the
Yeah,
sort of the short story. Did a bit of
absolutely.
consulting, did a bit of life at startups. So after consulting, I was at Rasa for a bit, then I was at Explosion for a bit, the company behind Spacey. I was like a lead, well, not a lead, but I was like one of the core devs on Prodigy for a bit there, which was a lot of fun. And now I do stuff over at probabl. I think is what a lot of folks at the company are French. So I think that's the way a lot of us pronounce it. Um, and we are definitely a company that tries to figure out a nice funding model for scikit-learn. Like we have a bunch of the scikit-learn maintainers that work for the group, and we're looking for ways to sort of figure out the funding behind that, make a proper company around it. Hopefully, a nice big one. It's nice to have more European tech companies. That's also kind of the dream here. But yeah, I'm part of that effort at this point in time.
That's super cool. There are lots of points of your history that I think that will flesh out in this conversation, but because we're doing a data ML AI podcast, let's focus in on the working at the bar at the theater, I think. Because you actually, and I can link to this talk in the show notes. You actually have a. So let's step back a bit. As we've said, we're here to talk about rethinking common approaches in data science, and I want to know what inspired this philosophy, how it's evolved over time. But you do have a story from your time in a bar that I think nicely illustrates some of the problems that we have in the space. So maybe you can tell this anecdote.
Yeah, so this is one of the anecdotes I gave in my talk. So it is a fun one. So I was working at a bar, and it was my first year of statistics class. It was like right at the end of the year, and when you're done with that statistics class, they kind of give you the assignment of now go out there and apply statistics, which is fair. You don't want to just do theory. You kind of want to find a data set, do something fun with it. And I remember some of my classmates, they would go and they would find like the Olympic medal results, and they found that there was a correlation between like if you want to win the Summer Olympics, population size helps. If you want to win the Winter Olympics, GDP tends to help, and they were doing all sorts of things like that. But I thought like, oh man, I maybe want to become like a consultant later. So what will be better for me instead is if I actually go out there and find like a business or a company or something like that and do like the consultancy thing with the data set. And the company I worked for was a theater. Now, this was a small theater, not the big one I would join later, but the small theater was actually looking at should we expand or not? Like that was sort of a question that they had. And they had like the growth numbers for every year. So you could see how many seats per average were taken in the first year, the second year, and this was like year 12 or something like that. So me being the naive first year student that I was, I figured, well, that's 12 data points. We can get a regression line to go through that. And if the regression line goes up or down and we can prove the statistics, that'll be good. Like this perfectly matches the theory that I had in my statistics book. Got a nice little curvy match. Professor was super happy with it. I presented it to the director. He was super happy with it. But the conclusion was that the number of seats that we were selling, that was on a downwards trend. Like we weren't selling more seats every year anymore. It definitely looked like the growth had stagnated. And I had a statistics model and everyone was convinced like, okay, Vincent, we should not expand the theater. So far so good. This was super cool. But then after I handed this in, I had to work on the night shift again. And the house was super packed. And like the day after, again, the house was super packed. And then at some point, I was like, hang on, the last 3 nights I worked here, the house is super packed. Uh, but I'm giving the recommendation that we should not expand. Like something feels weird about this. Then I started thinking about it a bit more, and it started dawning on me. Like a theater has a max capacity. Like if you're booked solid every single evening, then that's the reason that you're not growing. And then you can report on the fact that yeah, the growth is stagnating, but that's because also you can't sell anymore. You're at capacity. So basically, the regression that I was doing was Bobkiss. Like it made no sense to think about the problem that way. But the tunnel vision that my professor, of course, had didn't prevent him from giving me an A+ on this work. And this was, I guess you could say that this was my first experience with a proper vanity metric. Like it's very easy to take a metric that doesn't necessarily apply to reality and overfit on it. And yeah, this story comes back a whole lot of times when I give talks and stuff as well, because I think it's like a nice little anecdote. But one thing that is kind of ironic, but also funny in hindsight, it was also good that it didn't expand in hindsight, because 5 years later, the Dutch government would do like a massive, massive budget cut in theater. So they would have never been able to sort of make the money back.
Right.
But the reasoning was flawed, and that's the main point. Like if you're armed with theory, you can fail in practice if you're not careful. And that's like a common theme I keep on seeing.
Absolutely. So I am interested. This is a case of something that happened at a theater.
Yep.
I am interested in what the general failure mode happening here.
If I were to describe it in the most general way, what I think has happened in the last 10 years is at some point someone's claimed that data science was going to be the sexiest profession ever. So lots of people, lots of degrees, lots of curricula, and they all focused on like how do you get the best metric for an algorithm. And that's not necessarily a bad practice, right? Like you want your accuracy to be high and you want your mean squared error to be low. Like that stuff is fair game. But it is also a way of thinking about the problem. And that's, I think, where some issues can arise. Like, you can optimize for a metric, but what will be even better is that you worry more about if the metric matches reality in the first place.
Mm.
In my mind, there's like these two Venn diagrams. There's like this one Venn diagram, which is the stuff that your users care about, and this other Venn diagram is the stuff that we optimize. And when you have a data science curricula, you are focusing on how you optimize, basically,
Hmm.
but you're not worried about like, do these two Venn diagrams overlap?
Yep.
It's like, but and this phenomenon seems to translate itself into many different um like applications. I think that's something I keep seeing over and over again. Not everywhere, of course. Like there are also like really solid applications of machine learning. That's totally true. But it's almost as if this is something that can tell me if someone is like junior in their career or senior. Like if they're senior, they will have seen this go wrong and are therefore just a little bit more skeptical about optimal metrics. Whereas someone junior might be a little bit more impressed because they're taught to think this way.
Yeah, and so that's why I wanted to open with this example, which I think speaks nicely to how much you advocate for rethinking common approaches in data and machine learning. So I'm wondering just more generally what inspired this philosophy in you and how it's evolved.
Um, I guess there's two stories I guess that come to mind now at least. So a while ago I was at the Dutch BBC. The NPO is the Nederlandse Publieke Omroep. If you're Dutch, you'll know what this is, but it's basically the Dutch BBC. And they wanted to have a recommender, and I was part of a group that was there. There were also other groups there, and these people are actually relatively mature. Like they did do some of their homework, so they said stuff like, "Hey, when you see a recommender, like you're at the end of the video, there's like three slots where we can put a video, and that's stuff that we can recommend. We like it if people click on the recommender, but we also want people to click to actually watch the thing after." So they were aware of the fact that you could do clickbaiting. So like if we care
Mm,
about a metric that doesn't just summarize how many people click on the recommendation, we actually also care that people sort of watch the thing after. Like that's the thing that we're actually gonna judge the algorithm on. We're not gonna train on that phenomenon, but we are gonna judge the algorithm on it.
mm.
So that was cool, right? Like the sort of the management that was there was aware of the fact that you can optimize for the wrong thing, and they had thought about that beforehand. So that was like a really great feeling. Um, but there was also stuff missing. Like they hadn't built an A/B testing system yet. So even though there were people around me and also from like this other group that was definitely into like deep learning, they were telling us like, "Oh, can we do the deep learning thing? Please do that." And we had to disappoint them by saying, "Well, we should do an A/B testing system first because, otherwise you can't compare algorithms. It makes no sense to have an algorithm if you cannot sort of judge it."
Yep.
So they said, okay, fair enough. We build it. And then once the A/B testing system was done, they said, can we do the deep learning thing now? And we said, not really, because we have to test the A/B testing system. So we ran an AA test and we did that kind of stuff. So again, they said, like, okay, Vincent, can we now do it again? Can we now do the deep learning thing? And we said, well, there's actually this other thing we want to do. We came up with the worst recommender ever. So the idea was we're just going to give you like a random thing. And because you can imagine there's an order in which the videos appear. And if people click the first thing anyway, if that's like a thing that they do, then we want to measure that. If 2% of the people click the video and our algorithm only boosts that to 2.1% clicking, let's say, then you know that your algorithm's not really doing anything good because it's barely outperforming the random thing.
Yep.
So again, the deep learning people said like, okay, that actually makes sense. Let's do that first. And by this time, of course, like it's not just that we're building things. I'm also looking at data, doing a bit of data mining, trying to figure out what people are watching afterwards, etc. And then it just started to dawn on me that like most of the time people just watch the next episode of a show,
Mm.
and that's not in the UI. Like you have to go back a level and then click the next episode in order to do that. So my first algorithm was just the first slot in the recommender. Let's just have that be the next episode. And no one had thought about that because they were thinking like the group who was complaining about the deep learning algorithm had not considered the fact that maybe the next episode would be a good idea. And that to me was the biggest eye opener because that group had some pretty senior people in it. I believe they even had like a PhD or two with like background in writing very impressive papers and all that. But if you're so distracted from like, oh my God, I want to use the cool algorithm that you forget to recommend the next episode, then something really weird is happening in industry. And that was sort of the moment where I started thinking like, okay, maybe I need to not talk about like when I do talks at PyDatas and stuff, maybe I shouldn't focus in on how algorithms work, but rather how they're applied and how people are thinking about them. Because if people are forgetting to recommend the next episode, then we are in for a world of hurt when the AI winner is going to happen. Like that was just such a mind-boggling thing. I think this was like 10 years ago. And around that time, I really started rethinking my career as well, I noticed. So before that, I was really, really worried about understanding all the algorithms because that was I thought that was like the path forward. But then the clash with reality at some point just became way more interesting to me. So that's what I started focusing on.
That's a wonderful example. You mentioned there was a second. I've got some questions about that, but you mentioned there was a second example that came to mind as well.
Yeah, so this is kind of a weird one. Like around that time, I went to a little conference called Spacey in Real Life. Like this was they did this one conference, and I had never done NLP before, but I was at a PyData, and I saw a talk by Lynn Cherny. I hope I pronounced her last name correctly, but she did this one talk about word embeddings, and that just seemed so magical to me that that would even work. So I figured, okay, I need to learn about this NLP stuff. What's the best library? Well, back then it was definitely Spacey, and Spacey looked cool. So okay, I'll go there. And I was hanging out with the with the people who made Spacey. We went into a bar, went into another one. One bar was super busy, the other one was definitely more Spacey. That was like the joke I made that got the attention of Enos. And this is how we got the ball rolling. I ended up sort of making some YouTube videos for them. And while I was exploring the Spacey library, at least in Spacey version 2, I noticed something kind of interesting, which was that Spacey took an opinionated approach. Normally, if you're doing scikit-learn and you think about classification, then the assumption is that you're dealing with mutually exclusive classes. That is to say, we're doing classification. It is either A, or it is B, or it is C. Right? So we have a photo. There's either a cat or a dog in it.
Mm.
And you could do that inside a Spacey, but at least in version 2, this was a little bit harder because the Spacey assumption is, well, there's a sentence and there could be a label that we can attach, but we assume that they are never exclusive. So we can imagine instead of there being a cat or a dog in a photo, the definition would be more like, oh, there could be a dog in it and there could be a cat in it, but it's not cat or dog. And then I started thinking about like that's also kind of an interest that I don't know if it's like this was definitely version 2. I think in version 3 this was definitely nuanced a bit more because the community did want mutually exclusive classes to appear more directly. But there was also kind of like a little eye opener to me that like, oh yeah, like scikit-learn offers you a great API, but you can the way you define the problem, of course, is not set in stone. Like you can also make a little bit of a change to the way you think about classification algorithms. And it also makes complete sense because a photo can have a dog and a cat at the same time in it. But if the way you define your classification problem is, well, it's either cat or dog, right? Yeah, something about the way you define a classification algorithm there. There's also an opportunity to mismatch with reality there as well. And then the way I saw that in Spacey, I think, was like the first time that I saw a library take an opinionated stance there that mutually exclusive classes are not inherently the way the world works.
And on the flip side, so I love that example because it also reminds me on the flip side, in one of your talks, you give an example of binary classification that uses, it's a probabilistic prediction, which then there's a threshold to give a binary classification, right? And usually we set a threshold above which we'll classify as X, below which we'll classify as Y. And you give a nice example, which is kind of a counterpoint to this, whereby let's say the probability is between 0.2 and 0.8, I think is your example, actually. Maybe then you don't want to predict either of the things. You only want to make a concrete prediction after a threshold has been passed, and in the middle say, I'm going to not predict this, actually.
Yeah, that's the won't predict flag. That's the way I like to call it. Like, it would be nice if algorithm. So this is maybe because you've watched the same video, so maybe I should introduce this. So the thinking here is like, hey, we're dealing with a classification problem, and I'm assuming that we're dealing with an algorithm that has this predict probabl thing attached. So it doesn't say class A or B. It also just emits some sort of a probl value, and then you would hope that that probl value says something about confidence, and therefore you could say the closer you are to 0.5, the less confident you are about a decision. So maybe we should add some wiggle room there that we don't automate every single decision out there. The algorithm is only allowed to automate a decision if it is quote unquote confident. And that was sort of the premise. But I think the point that I was this was the one where I show that that's not enough, right? Like that talk, I think.
Yeah.
Yeah, exactly. Now, so like the idea there is, of course, like pretty sound. Like a lot of the algorithms, if your predict proba is like 0.9, you can assume it's more confident than 0.8. The only issue is that you can still have a proba of like 0.999 and the algorithm can still be wrong.
Yeah.
So the question is like, how much faith do you want to put in that predict proba thing? Or is it maybe not enough? And the main point that I'm making is outliers in that talk. So if you imagine like yeah, like the sigmoid line. So like on one, there's like a splitting line in the middle. On one side, we've got blue dots. On the other side, we've got red ones. Then we can say like everything close to the splitting line, that's uncertain. But then if I take an extreme example and I say, go 6 miles away from the closest blue dot, but on the left, but on the side of the line where we have all the blue dots, let's say, but it's miles away, we've not seen anything like it. Well, then the proba value can still be super high, but it's unlike anything we've seen before. So maybe a good idea would be not just to say, well, let's take the proba value as a confidence measure. Let's also do outlier detection while we're at it. So if we can confirm that this is something so like it's so far away from the bell curve, we can't hear it ring anymore, right? Like really, really far away. Then we should also just raise the won't predict flag. It'll be a different reason to raise the flag, but there is more than one way to not automate a decision. And again, in my mind, at least, if you're so trained to think about classification systems, that you care about that predict proba value and that proba value is going to be a proxy for confidence, then it's going to be hard, I think, for you to take a step back and consider there's also other ways of doing it. And that's kind of the point I want to make in that talk. The talk, I think, is called Constraining Artificial Stupidity. So that talk is all about like techniques that you can constrain stuff like that from happening. But if, yeah, to take the general hat again, it is also the same of take a step back and rethink the approach, because there's usually more than one way to go about it.
Yeah. And that's what I want to get into next. I do want to just kind of elucidate something here, which you do clarify in that talk, among others, I think is part of the challenge here is that machine learning algorithms and statistical modeling more generally, particularly good when they are at interpolation, but not extrapolation. Yeah. And when we're dealing with outliers, we're trying to extrapolate to essentially out of training set stuff where whatever signal we've discovered just may not apply out there. And like we don't have our posterior after seeing the data, and we can get into Bayesian stuff later, actually.
Sure.
But the posterior is still relatively broad out where the outliers are.
Yeah. I mean, you can do stuff like, okay, we've got our data set and I don't know, like Gaussian mixture model your way out of it. Maybe like you can maybe say something about like, okay, this data set probably has a distribution behind it. If we can model that distribution, we can also do something with like the likelihood values and stuff, and that might be a way out of it, you know. But in the end, like another way to maybe also think about it, and this is something that's like a theme that also comes back in my talks. You can kind of imagine that there's like a real life problem, and then we're going to take that real life problem and then translate that into something analytical. And then in the analytical domain, tensors flow, we do our thing, and then we get like a 10% boost or something like that. And that's also kind of what's happening here. Like in the end, I don't care about the classifier. In the end, I care about how the classifier reacts to reality. But what's always the case here is that we make a translation from real life to analytical domain. And when we have a 10% boost, you can wonder, well, if we translate it back to the real world, how much translation error do we actually have? Does the 10% boost compensate for the translation error that might be happening? And if not, then maybe we should worry more about the translation error than the 10% boost that the algorithm gives us. Like that's also a way to think about it. If the analytical boost is small, but it really maps well to reality, that is usually way better than if your analytical boost is huge, but it makes no reflection of reality whatsoever.
I couldn't agree more. I think this also speaks to something we've been talking around is focusing on the problem rather than focusing on the solution, right? So to take which of the I think the recommended system example is the most obvious case of this out of the ones we've discussed, right? Where you want to recommend something to someone, and perhaps the next thing that you'd think someone would watch intuitively is a good approach, as opposed to start using deep learning and neural networks. So maybe you can speak
my
to that.
favorite example of this, and it's from the same talk. In the weirdest possible way, I ended up talking to someone who helps out with the World Food Organization. So, a little bit of background. So my master's degree was in the end in operations research, and that field is all about like optimizing logistical chains, traveling salesman kinds of
Mm,
problems. Like pretty math heavy, but really interesting stuff too. Um, but okay, like traveling salesman kind of a problem, like that kind of logistical scheme. And you can maybe imagine at the World Food Organization, they are allocating foodstuffs and they would like to do that in a cheap way. So this logistical part of the equation is actually not unsubstantial. Like the transportation costs are kind of real here, as well as like the cost of goods and all that. Um, and the way that they used to work was they would go up to quote unquote a village. They don't actually go to a village, but what they do is for certain regions, they ask quote unquote the region, like, hey, what foodstuffs do you need? And they would say something like, okay, we need, I believe what they used to do was something like, okay, we need this many kilos of beef, this much beans, and then, they would list the foodstuffs that they would need. Uh, and, they have PhDs at their disposal that work on this, and they had been working on this for years. And you can imagine that, like, this is traveling salesman problem kind of stuff. Algorithms for this, they don't scale very well. Like, it's very hard to parallelize. So you might have to wait for weeks until the big machine is done finding like the optimal allocation.
mm,
Um, the tricky thing here with all of these operations research algorithms is that if the world changes only a little bit, you have to rerun the algorithm. Like the price changes of a good, then the allocation is bad already. So, okay, so like this is a really tricky technical problem. And I do have great respect for people who make progress just in that domain because it is fundamentally hard stuff. But then someone just observed out of the blue, like they don't need beef, they don't need beans, they need nutrients. Like if we're dealing with people that are facing hunger, then they're not going to be that picky. Like if we can give them lentils instead of beans, who have like a very similar like nutrient profile, right? Um, oh, hang on, maybe the algorithm is forced to look in a search space where the optimal solution doesn't even exist. And the what I probably have the numbers wrong because this was 10 years ago, but what I was told is that this observation and then switching to a simple algorithm to deal with that led to a 5% reduction, which, they would be usually they'd be happy with like a 0.1% reduction after a year of research. But this was like 5% overnight with this one observation that fits the world better. And, this is one of those moments where lives are properly saved. And this is also, I think, the best example of you can have the best algorithm, but if you apply it to the wrong problem, it doesn't matter.
yeah.
And if people like one philosophy that relates to this is uh his name is Akhoff. I forget his first name, but he was this person in the 80s and 90s who he used to be an operations researcher, and then he pivoted to systems thinking a bit more. Like he was one of the founders of the systems thinking domain. And he also has this nice example of if you're designing the
Russell,
best car. Sorry?
Russell Ackoff,
Yeah,
maybe.
could be. Russ, I think so. But he has this one analogy also in one of his books where if you're trying to design the best car, the way you get there is you don't design the best engine and then the best exhaust pipe. You get there by figuring out how to hook up a really good engine to a really good exhaust pipe. But if the communication between two parts is broken, it is simply not going to work. And it's also like if you're in consulting, by the way, this is also like a pretty good analogy for your day to day. Like instead of worrying about optimizing one thing, if you try to optimize the communication between two things, then usually it's easier to claim that you've made an improvement to the entire system.
Mm.
And something like that is also happening, I think, in other domains. But that, like, usually that's the stuff that matters. Like, can I have a cog that fits the system better? Because just having a better cog doesn't mean that it's a better system. Like that, I think that message and that analogy holds a lot of truth in it in general.
Well, this actually speaks to a far greater point as well, I think, which is what are we actually doing? What are we building, and why, right? So you've spoken about the challenges of what happens when we're optimizing for area under the curve and this type of stuff, F1 score, and all of these things, when perhaps we should be doing more design thinking and thinking about product and experience and this type of thing in a lot of cases. So maybe you can speak to how systems thinking can help us with all of these things.
Yeah, I mean, so the easiest explanation is a story I just gave you. Like it's always good to be aware of the fact that you might be chasing a vanity task, right? It's very easy to sort of say, "Oh, I have a classification problem. I'm gonna optimize the heck out of it," and not necessarily worry if the labels are correct or like where does the data even come from, and then like that sort of a thing. Um, like some of it is also just, and like, this is a weird and interesting exercise, but something I have seen go quite nicely. I used to work at Dutch eBay. It's a site called Marktplaats, and one thing they did, which I just thought was really, really cool, um, they would just have like random users, and they would show them a new feature, and developers were forced to sit in on that session. So
Right.
like they had like a new feature. Let's say it was like a new bannering system or something like that, and they would say like, "Hey, you've just clicked around the website. You can see your front page update. Does this change make sense to you?"
Mm.
And then very often they would say, "Nah, it makes no sense to me at all." And then like, what could you answer why? Well, because for years I've been looking for this one thing, and the banners have now all changed because of my recent searches. And then the engineer would go, "Well, isn't that what you want?" And no, 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 I want to be able to configure this.
Yeah.
And just having like a human tell you that in your face. And this is maybe also a Dutch thing. Like the joke I always make is we're Dutch. Like we don't like to stab you in the back. We prefer it if we just stab you in the front. It's much quicker that way. Like something about like being punched in the face of reality, like exposing the engineer to the end user. That was really beautiful to see. Uh, so I don't know if they still do that practice, but I thought that was like a really, really beautiful thing to actually do. Just have the actual human being in front of you, and when something fails, you can actually see how it fails. And something about that is just so much more information than like looking at logs of the website in a way, right? So the one thing is data, the other thing is just information, and this is like insight. Like that's the top of the line knowledge you can get.
Without a doubt. And that's why I said almost facetiously at the start of this conversation when you mentioned if you're designing a wheelchair, it may be useful to sit in a wheelchair
For a
and use
week.
one. And
Yeah.
yeah, for a week. And I said, oh, who would have thought slightly cheekily, I think. But I mean, we are discovering this a lot in our space. But I think part of the challenge, one of the big failure modes you're speaking to is people just don't understand what the end user needs or wants or experiences,
Well,
and however they
one
can
thing
appreciate that or have to have empathy.
Well, I think there's also another avenue to this, I think. So one thing that I'm really thankful for is I mentioned I have both a background in design, like design thinking, but also in operations research.
Mm.
So in operations research, one lesson they do really, at least that's what my professors did. They really drilled this one in me. So you got to imagine in operations research, let's say you do traveling salesman problem, you need to know the distances between the cities or the cost between the city, like how much does it cost for a truck to go from A to B.
Mm.
If you're going to make the optimal allocation there, you really need to make sure those costs are accurate. Because the constraint is not going to be useful unless like the constraint actually matters, right? Like you're gonna get the wrong allocation if you don't think about that. And the same thing holds for like cost of goods that you're purchasing and that kind of a thing.
Mm.
But one thing you can also imagine is that, hey, I am trained in thinking about algorithms in a very constrained way. Oh, constraints actually don't appear that much in machine learning algorithms. Like they might appear inside of a solver or something like that, but like, oh, hang on, I'm used to thinking about constraints. Wouldn't it be cool if I could tell my algorithm, hey, here's like optimized for accuracy, but only if these 5 examples get the right class. Like that's a constraint I want to just attach to my algorithm, so to say. So I think part of the solution is also that maybe we're trained too narrow as far as like what can algorithms even do. Like we do have mathematically sound algorithms to add constraints to systems, and if they're quadratic, which most linear algorithms are, we can usually have like a closed form solution to add constraints to our classification and regression tasks. And I also like to think that there are these tricks and techniques from the realm of search, and like there's all these different algorithms and techniques and computer science that we can build upon. A part of me sometimes also thinks that we have lost a lot of creativity by only focusing on like one way of thinking about the algorithmic system of the problem. It's not just always the match with reality. It's also just like, hey, there are like all these fancy algorithms out there. Not all of them are deep learning. And sometimes they can also cause some inspiration too. We'll see an example of that at the end where I have a demo of this. But
Exciting.
like that's also if like I really, really wish earlier in my career that I did this more. But like to give you another example, like imagine you've done deep learning and you've done scikit-learn, but you've never done PyMC3 or the Bayesian thing at all, right? Like the Bayesian way of thinking about the problem, oh, actually, that is super. That can really help you like get out of a problem sometimes. But it's a very different field if you look at like the classic assumptions and all that. So like that's also an escape hatch. That's also a way to think about it. It's not just always like talk to people and like how does the business work. Sometimes it's also just realizing like there are like so many tools you can consider, not just one.
And I wasn't going to mention this yet, but of course, your way of thinking has. So you work in education, in building product yourself, and working with algorithms, data, that type of stuff. But you've also built packages around the type of stuff
Yep.
you think is useful. So perhaps you could tell us a bit about Scikit-Lego and how that evolved, and then how that
Yeah.
has to do with Scikit-learn now.
Uh, there's okay. There's a few anecdotes here, and I am one thing I do want to mention up front is I am going to brag a bit. Depending on who you talk to, they might have a slightly different story. But we just reached 1 million downloads, so I'm definitely going to brag a bit. Um,
Congratulations, and that's for
yeah,
Scikit-Lego.
yes, Scikit-Lego has
Amazing.
reached 1 million downloads. That was like get celebratory drink. Um, Okay, so I used to work at this company, and at some point I just started noticing, like, when I go to a different client, there's just a few of these scikit-learn components that I just always re-implement, really. Um, and people around me thought it was a bad idea, but I did think, like, I don't want to rewrite this stuff all the time. I would prefer to have that, like, be somewhat open source, also so other people can contribute cool ideas. Because there are also just some of these, like, weird components that for sure shouldn't be in scikit-learn core, but it makes sense to have a few of them around. And, uh, I had some time series tricks, for example. There's some seasonal patterns. Like there's estimators for that. So I figured, like, okay, I need these Lego bricks around. So me and this one other colleague thought, like, hey, one thing that's actually kind of cool is we also teach this code stuff sometimes. So his name is Matthijs. Me and Matthijs, we said, you know what? We'll just have an open source project and we'll just tell our employer it's also going to be useful for training. And it actually was, because one thing we could do during a training is say, today you're going to learn how to commit to an open source project. Like we could do that in a day because we can troll the repo and we can kind of show what it's actually like to make an issue, make a PR and all that. So that was like the original reasoning behind it. But then me and Matthijs just started challenging ourselves. Like, what if we actually took this somewhat serious? And what if we actually started adding genuinely useful algorithms to this? Like, what would happen if we did that? Um, so then we opened up the project. We said, like, hey, anyone who can give us an algorithm with a benchmark that convinces us it's a good idea to host it here, we'll just accept it.
Mm.
And then Matthijs also did some good work in implementing some algorithms for like algorithmic fairness. So if you're interested in like mitigating some bias, like we have some features for that. This was like almost 7 or 8 years ago. So we also added some support for pandas conversion inside of Scikit-Lego, and a whole bunch of stuff got added. Um, but it's now a few years later, and a few interesting things have happened. One of which is that some of the algorithms that started in Scikit-Lego have found their way inside of Scikit-learn. So Scikit-Lego had a quantile regressor, I think, a few years before Scikit-learn did. But one thing I do like to think is that what Scikit-Lego is really good at is just getting ideas out there. And if people end up liking it, then more serious projects, if they really want to, can sort of pick that up. And that's, I think, kind of the story here. I'm still a maintainer. I still hang out there. Matthijs is definitely doing some other stuff now. So we were looking for a new maintainer. So we have someone called Francesco. If he might be listening. So once again, Francesco, thanks for all your effort. You've really been helping out here. Um, so we've also got some new faces in the mix that are also contributing new ideas. But the whole point of Scikit-Lego, at least for me now, is that it should be just fun to maintain, and hopefully it should inspire some people to play around with different ideas. And I think it's pretty good at that. Like it's not it's definitely not like one of the biggest Scikit-learn plugins or anything like that, but it is big enough for people to at least sort of play around with it. And that's been like fun and cool to see.
That's awesome. I've linked to it in the chat and in the show notes. I'll put it there as well for those listening.
So
I
one thing that is, if you want to have a blast, you know how in Python you can import this and then it gives you a poem. Most of my open source packages have a poem as well. The one in Lego is all about the fact that we really don't want to have a fight with Lego's lawyers.
That's fantastic.
Because it is a copyrighted term, and we are really making it clear in the import this poem that we are not interested in copyright law.
Great.
But do import this when you're playing around with Lego. You're probably going to smile a bit.
I will. And not only does import this in Python give you a poem, it's not any old poem, it's the Zen of Python.
It is deep. Yes. Well, and so this is actually something I learned from SymPy. So SymPy was the first open source project that I saw that also just did this. And Lego, the way Lego goes about it is, if someone contributes a pretty big idea, we tell them like, hey, this is a meaningful contribution. If you want to, you can add a line to the poem in this. Like, what's a lesson you learned while maintaining Scikit-Lego? So like the first paragraph of the poem is about like, please Lego, don't sue us. The rest are actually like genuine lessons we've learned while maintaining this thing. And I do want to share like one part of it actually. Scikit Lego. Because I think we have the poem. Yeah, the poem is also just online.
Are you going to read me poetry, Vincent?
Yeah, it does seem to. Yeah, so it does seem to be happening. So there's a lot of power in simplicity. It keeps the approach strong. If you understand the solution better than the problem, you're doing it wrong. Like that was a good one. And there's another one, Command F. Yeah. Be careful with features as they tend to go sour. And this is my favorite one. Defer responsibility to the end user. This might just give them power. So one thing we've stumbled across in Scikit-Lego is at some point there were users that had like pretty good ideas, but it did feel at some point that the library had to really think of every single concern. And at some point we figured, well, we can also just document that something is a concern, and we don't have to implement every single thing, because in the end, understanding the problem, that's the responsibility of the end user. Like that's something a library can't do for you. So we also made a very conscious decision of we're not going to implement everything because some responsibility has to be with the end user. That's something, a lesson I did learn while maintaining Lego. I think that's my favorite line. But anyway, there's lots of like cool stories in that poem. Please, if you're gonna play around with Lego, read that. It's my advice.
Fantastic. And as you know, I mean, I've been podcasting on and off for years. What year is it now? 2024.
24.
Yeah, mate. Yeah. At least 6 years or something like that. And this is the first time anyone has recited poetry to me on a podcast, Vincent. And I gotta say, I don't know if you can see under this beard, but I am blushing real hard.
Oh, right. Okay, then okay, fine. Then I'm gonna read you the first paragraph.
Please.
Roses are red, violets are blue. Naming your package is really hard to undo. Haste can make decisions in one fell swoop. Note that Lego is the trademark of the Lego Group. It really makes sense. We do not need to bluff. Lego does not sponsor, authorize, or endorse any of this stuff. Like that's
that is awesome.
That's the first paragraph of the Scikit-Learn. Like this is the Zen of Scikit-Lego.
So everyone, pip install or poetry install or pixie add Scikit-Lego and import this and check that out. I want to now move on to, we've mentioned kind of the importance of focusing on the end product and what you want to measure there, and what you want your success to be. Of course, at the other end is data, and the data generating process. And so going back to you, I just want to go back to you in a bar, while at college, making drinks in a theater. But the reason that's the case is because I do think that's a really nice example. If you think about the process, I'm not even talking about doing any of the mathematics or statistics. If you sit down and write down what you think the process that is generating the data will result in, you may come up with the idea of the capacity of a theater. And as opposed to
you're exposing yourself to the problem. That's the way I would phrase it. Yeah.
Yeah, I like that. And I haven't quite thought about it like that. But I jokingly say I'm probably a Bayesian.
That's a good joke, actually.
But I thought you'd like that.
Yeah, that's a nice one.
But and one of the reasons for that is that for me, I mean, it's a shame it's called Bayesian in some ways, because we all joke it probably should just be called statistics, and statistics could have another name. But all jokes aside, it does force you to explicitly write down your assumptions and the data generating
Yeah.
process. So I'm wondering, and of course, in one of your talks,
I
you
mean,
also mentioned PyMC3 and how that can be used to model certain things. So Bayesian
I
stuff
think,
aside, maybe you can tell us about the data generating process and then talk about kind of the pros of Bayesian inference here.
yeah. So like, okay, so I'll start with, so sometimes it's also about finding the right word, right? So like a year ago when I was preparing a keynote, I noticed like, hey, yeah, exposure is maybe the right word. So like exposure is the word for like, how do you actually understand the problem? Well, by exposing yourself to it, not by hiding from it. And similarly, I was also thinking about what is it about this Bayesian thing? Like there's a word that I was sort of missing. And then the word that I think describes the Bayesian stuff pretty well is it's very articulate.
Mm.
It's not a black box. Like it's pretty, you kind of have to write down what the assumptions of the entire system are before you say dot fit.
Yep.
And also like in hindsight, you can sort of look at some of the numbers and say, um, like, oh, okay, does this distribution make sense? Like that, and it's very explicit, and something about that makes it very articulate, and that's something I kind of like about it. Another way to think about these Bayesian systems, and it's this is one of those things where it really helps to have like a presentation ready with some charts. But one thing if you look at where Bayesian systems are typically used, a lot of that is in the A/B testing system domain.
Mm-hmm.
Like if I talk to people at Booking, like a lot of people like PyMC3 stuff because of the A/B testing nature of it.
Yeah.
Um, and one way to maybe think about that is like, I don't know, like suppose that you have some sort of hypothesis that like, okay, I'm going to go over with the Booking example. Booking is probably not using this example, but Booking is like one of the bigger employers in Amsterdam, which is why I'm going for them. Okay, so I
And
have a
also a
website.
place that has like done incredible work in online
Oh,
experimentation and A/B
oh yeah,
testing
they're like,
and such things, right?
it's very hard to spell A/B testing without the word booking in it these days. Yeah, like they have some good papers. If you go to the PyData talks, like there's a couple of really solid talks. They all come from that like little garden, I suppose. Um, but I don't know. Like let's say that I am booking. I have a website, and there are some hotels that claim to be kid friendly. And let's say that some of these hotels also offer business suites, and sometimes people book and they um, something about their order makes it very clear that they've got kids. Then already very quickly you want to calculate stuff that sounds like, okay, given that the family that's booking right
Yeah.
now has kids, what is the likelihood that this matters? And there you already kind of go. Like you are very explicit about the information that is known up front. Then there's something very explicit about like the experiment that you're doing or the subgroup, and then you're interested in inferring some knowledge, which is like quantified in a probabilistic way. But you have to be very explicit. Like you really have to say, this is given, and that's the thing I want to measure, and these are the other variables that I want to measure the effect of.
Mm.
And if you're interested in doing the A/B testing system, like, oh, then I really want to know what is the effect of this thing to that thing, keeping everything else in mind. Um, there's also a really cool causal little example here. Like, have you ever exposed yourself to the smoking data set?
No.
Ah, it's one of my favorites. Okay, so the smoking data set has.
Oh no, is it part of Calm Code?
Yeah, that one.
I discovered it through you. Yeah, through Calm
Yeah,
Code. Yeah, some time ago though.
we'll talk about comp code later because it's also a thing I do. But the really cool the smoking data set has a really cool lesson in it. A lot of data sets do, but this one is just so explicit. Okay, so if you've got a data set and there's a couple of variables in it. One of them is quote unquote health, which is basically, do you still live after 10 years? The
Mm.
other variable is, are you a smoker? And the other variable is, what is your age? And what you can do is you can say, I group by whether or not you're smoking, and then I track whether or not you are alive in 10 years. And when you do that exercise, you're doing quote unquote statistics, and you come to the very reasonable conclusion that smoking is indeed good for you. Because people who smoke, they end up being more alive after 10 years than people that don't.
Mm.
And this is kind of a conundrum because are we lying with statistics or what is happening here? But then, you know, the pattern that you're really measuring there is that people who smoke are typically younger. Like people, at least if I look at my friend group, most smokers stop once they start having kids. Like something responsibility happens when the kid's around. So yeah, okay. If it's mainly the younger people that are smoking, and we're checking if they're alive after 10 years, yeah, then you're not really capturing whether or not, if you're just averaging on the smoking, you're going to lose too much information. So the way you should model this instead is you should say, well, whether or not you smoke is dependent on age. And given that fact, then we can say, okay, and whether or not you're alive in 10 years depends on smoking, given that your age is a thing and your age. And when you do it that way, then you can see that there's a negative trend when you're smoking. But it's completely hidden if you don't include this one fact about the age. And again, this is why Bayesian models are, in my book, are considered to be articulate. But you do have to sort of do this exploration yourself a bit. One thing is also what I think is so nice about this example is you're able to learn this lesson because there's a column called age in the data set. Imagine if that was missing. You would totally get to the wrong conclusion.
Well, that's part of one of the biggest challenges, I think, when thinking about causal inference. And we don't necessarily want to get too much into causal graphs and that type of stuff. But what
it's a field of its own.
Yeah, in your lovely example, you can take age and put an arrow from age. You've got a graph. Age is a node. Arrow to smoking or not. Arrow to survival, death, that type of stuff. Not that type of stuff. I didn't mean to be flippant about survival or death. But my point was that it's impossible to know if ever your causal graph is complete. And if you don't have the age column, then like what other things do you want to take into consideration?
Well, and here's my point. Therefore, the data set will not be enough. Like that's the main conclusion of the smoking. Like that, if there's there's actually two stories, I suppose. Like one story is the way you model sometimes really has to come from you. Natural intelligence is still a good idea. Like that's I think a lesson. Yep. Another other lesson that I think is really cool about that data set. Why on earth are we taking 10 years from now? Are you still alive? Why is that the best proxy for health? It isn't. Let's be real, right? But again, both of these very important conclusions, they come from a human. They don't come from the data set. They don't come from the algorithm. They only come from you. Like natural intelligence is all you need, kind of an approach. So again, like, I'm passionate about this sort of thing because it sometimes does feel like I'm the only one talking about this stuff. But I do think it really matters. If we really want to prevent artificial stupidity from happening, these kinds of ways of thinking are maybe going to help us more than throwing more tensors at it. That feels like a very easy hill to defend in my book.
Absolutely. I mean, it's challenging when at the same time a lot of like the cultural consciousness is obsessed with like how many GPUs you can fire up simultaneously. But cynical snide remarks aside, there's so many interesting stories and ways of thinking in here. I'm wondering if there's some way we can kind of collect them all into just thinking, is there like a list of the most common mistakes that people make in order to, I'm trying to reduce it down to a few takeaways.
Yeah, I mean, okay, I guess this is like a really good segue to a book I'm writing. So the way at least I started thinking about this is like people have come up to me after my conference talks, and they all kind of came to me like, Vincent, where do you learn all of these lessons? Because they seem kind of valuable. Are they in a book or something? And I've always kind of said no, but I talk to people and I expose myself to problems. And I do want to admit it has always been relatively easy for me because I used to have an employer that would basically pay for all of my conferences. So I would totally go to lots of conferences. I would totally drink beers with people, and I would totally hear stories. So like I've been able to expose myself to a lot of interesting anecdotes that way. But it's kind of like this cautionary tales thing. I think that's the way to think about it. It's not like there might be a few general lessons out there, but maybe it's also about recognizing the patterns in all of these stories. So what I've figured I might do, and I've been telling people I should do this for a year, and I finally actually started doing it. So my goal for the next year or two is to just start writing these stories down some way. So you just have a little book, and the title of the book is Data Science Fiction, where the whole point is that we are just going to have a resource where lots of these stories are that people can just go ahead and read. And hopefully when they have like their business use case, they might think like, will this work, or is this going to be data science fiction? Like, is this going to be something that we tell ourselves is going to work? Or is there maybe like cautionary tales that would be of help? I do want to give maybe one shout out though, because one project that I am very impressed by in this realm is the Dion checklist. The crew over at Driven Data have made this. It is a very, very sensible checklist of things you want to check for when you're doing data stuff in practice. And everything that can go wrong that's in that checklist is backed by newspaper articles of something actually having gone wrong. So if you want to have a conversation with your boss about it, you can actually pull up a newspaper article and say, like, this could also happen to us. Like the Dion checklist definitely is like one of the most underappreciated resources in data science in my mind. But the goal of the book is to actually be a little bit more story driven. Like there's going to be some fiction in there. There's going to be some charts, but it's basically going to be like instead of me waiting for another conference to happen to share some of these anecdotes, I'm just going to write them down in a little book. And the book's going to be, I'm going to show the link at the end, but there's also like the first 3 chapters are up and everyone can just go ahead and read them.
Fantastic. And I'm excited to chat about them as well. I've included the link to the Dion checklist in the chat and the show notes. And I've also included a link to an essay or a set of essays that DJ Patel, Hilary Mason, and Mike Lakides wrote in Northern Hemisphere summer of 2018 called Of Oaths and Checklists. Something I think about quite often. And I think it may be what inspired Peter, Bull, and Isaac, and all those people, all those wonderful people at Driven Data. I could get that wrong.
Yeah, no, so it is sort of the same. It is a similar social circles. Like I can see Venn diagrams overlap there, and it's also like the same time frame, so it wouldn't surprise me.
Yeah. But one of the points of the essay essentially is to people were talking a lot about data scientists, the practice maybe having oaths or something along the like the equivalent of a Socratic oath or something like that. And this piece is positioning the idea of checklists along the lines of the checklist manifesto, which I'd highly recommend to everyone. Also, are you doing a live stream today with the people from Driven Data? Or is it?
Okay, I guess I can also, on behalf of my employer, Probabl, I do a podcast called Sample Space. And yes, the next guest is going to be Peter from Driven Data. And I will be interviewing him later today
Cool.
about the Dion checklist and other stuff. Because I think it's a really cool project. And it's also relevant to stuff that we do over at Probabl. So that's like a very typical guest I would have on the podcast.
Fantastic. Well, definitely check out Vincent and Probabl's podcast as well. I'd like to jump into a demo soon, but I'd like to get your thoughts on, something we've been talking around, something you argue for a lot is the value of simple interpretable models in a variety of different scenarios. I'm just interested in how you balance this with the push for more complex and potentially more powerful models as well.
I mean, there's a couple of attitudes to have. Like one way to think about, I gave a talk about linear models, like how to win with simple linear models, and I think there's still a lot of truth to that. Like the sort of the internal joke over at Probabl is that we have the Vincent benchmark. Like, did you also run a linear model, and how did it compare to that? Like, if you haven't done that exercise, then please do that, and otherwise, Vincent's going to be angry.
That's almost equivalent to like a majority classifier in the binary classifier.
It's a dummy classifier. Yeah, it's basically this is Vincent's baseline. And one thing that I've always kind of noticed is if you force yourself to just do the linear model thing for a bit, then you also force yourself a little bit more to get value out of your feature engineering, which also forces you to think a little bit more about your problem. So I've always also appreciated this exercise kind of as a forcing function.
Great.
That said, I do want to mention that there's something cool about the LLMs that is a bit new, and I do think it's actually kind of useful. And this is something that back at Explosion we definitely did experiment with. So a trick that I've always loved using when figuring out data quality is having 2 models. So let's say you've got one model that's on the relatively simple side, like very rule-based, maybe like a Python function with some domain knowledge from a colleague. Or if you're doing NLP, it's like a relevant words list, and if that word appears, then match. Like it's a relatively simple classifier. You think about it, it shouldn't be stupid, but it should be relatively quote unquote simple. That's kind of the goal there. Oh, and then the other model you've got is the hella deep learning, mega XGBoost, mega black box thing. Just worry about accuracy on that one. Now, what happens if they disagree? Because the cool thing about it is, like, even if you have lots of unlabeled data, you can still train two of these models on a relatively medium small subset. But I have found just in practice, it's not like you can throw away all of active learning, but just when two models disagree, something interesting is usually happening. Like either there's a misclassified label which you can use to improve the XGBoost model, or you're going to notice a pattern that's not in your rule-based system, and both are very valuable in the end. Um, and coming back to the LLM, like one thing I do think is really cool about it is because it's so promptable, you can always have in the back of your pocket for a lot of NLP tasks, have a not necessarily perfect, but you do have access to a second model. The only thing you need is a prompt. And you do have a model that should be able to do a bit of classification in NER. And I recall a lot of benchmarks we did over at Explosion, like they're not perfect or anything. And we have found that if you get like 5,000 labeled examples or so, a lot of the spacey models can outperform these LLM models on a lot of tasks simply because you've got more labels at your disposal. But in that beginning phase, as you're labeling, okay, that's actually not a bad use case for an LLM. Like use that as the always available second model and keep the human in the loop. I think that's a very legit use case. And I do think there's a lot of value in that. So I'm not so one. I am a little bit against maximalizing the LLM. Like I'm not an LLM maximalist or anything like that. But from a distance, I can look at a few of these use cases and go, "Hey, that's actually kind of cool." But the human is still in the loop. Like that's the only thing I would add to this. Like the moment that you automate the whole thing and don't keep the human in the loop, then I do start getting a lot more critical. Um, the main shame is that you do have a lot of LLM maximalism going on. It's kind of weird to see how in industry it kind of felt like, oh my God, we've got ChatGPT. The company now really has to do something with this, and that caused a lot of proof of concepts, but not necessarily great engineering practices yet. That's kind of the vibe I'm getting from people in industry. There's a lot of proof of concepts, not necessarily a whole lot of stuff in production, and not necessarily a whole lot of proper engineering. But there's been a bit of FOMO, which caused businesses to start taking this stuff a little bit more serious. And I wish people would not use FOMO, but use curiosity a bit more. But again, always having that, there's a Spacey LLM package people can check out. That's pretty good. Like that, it makes it easy to configure an LLM as a backend, and you get like a Spacey object back, and like that stuff just works pretty well. But having a good second model for always at your disposal for NLP tasks, that's cool for labeling. That's clear use case. I'm convinced that that's actually fair.
Yeah, I think that assessment's pretty reasonable. I will say on you in within that, you mentioned that people are finding it difficult to productionize certain things with LLMs and or like integrate them into, traditional software systems and software stacks. I'm paraphrasing slightly.
Sure.
But there is an argument. I will not make this argument now. I've made this argument before, but I would. This is not an argument I'm making now. But there is, I think that there are strong arguments that LLMs, the way that they've played out, are almost antithetical to software. I mean, if in terms of building software, we want it to be reliable and correct, for example, and consistent, LLMs are definitively not any of those.
So make that a small cog in the system, but still have the system, right?
And have a box around it as well. Don't necessarily, make it the big brain. I mean, we do have this when we think about agentic workflows, for example. We have a big brain that sends everything out to everything else, essentially.
Well, or just not have it automate the thing. That's also a way to think about it. And maybe an anecdote, something I did learn over at Raza is, so let's say you're a chatbot scenario, user types, hello, my name is Vincent, I would like to order a pizza. Let's say that that's something a user typed. Then you can infer that the user's name is Vincent. In the case of Vincent, that's relatively easy because Vincent is a relatively common name in English. So like that'll be somewhat easy to detect. But one of my high school buddies, his name is Fuad. That's a less common name in newspaper articles in the West, and therefore probably also a harder name to detect by an LLM system. So what do you do? Do you automatically detect the name and move forward, or do you just have a step in the chatbot that says, "Hey, just to confirm, is this your name? Yes, no button." Right? And that's also, and like this is also a general theme. We're going to see an example of that in a bit. I also feel like a lot of machine learning problems are actually more UI problems. So do we really need to have a bigger tensor for the retrieval, or do we need to have a better interface for the user to find the thing that they're looking for in search? Like when is, or like, can we do something clever with icons instead of having everything be text? Like stuff like that might be more the thing that a user is interested in. One of the coolest chatbots that I've ever seen was a bank in the US. I forget which one, but they had a chatbot which is basically almost like a form, but the chatbot would just be there to help you find the button in the menu somewhere. So imagine that you've got your iPhone and you're trying to find that one setting that changes the Bluetooth to like, I don't know, there's a really deep menu, but the whole point of that chatbot was just to get you to the right part of the menu. And the iPhone app would just kind of update. It was kind of like a nice experience, but it was basically, oh, here's give me the two questions, and it would be like a session. You didn't have to like do the search thing once. It would just do a follow-up question after. But is that really chatbot technology, or is that also just UI? And in my experience, a lot of it really should be UI. Like that's probably going to be the easier win. Um,
I couldn't agree more. I
yeah.
want to jump into a demo, but before that, I am wondering.
I mean, I have the time, right? So go.
Yeah, yeah, exactly. I am. If someone had, one takeaway from this conversation, about how to rethink data science and machine learning, what would it be?
Try to expose yourself to really different problems once in a while and then reflect. Like that's kind of the tactic that I've been doing. So just to give an example, you've been hanging out with Hamal and like the crew that just did this big LLM course thing. I basically signed up to that, not because I was particularly interested in fine-tuning my own LLMs, but just because I felt like exposing myself to that field. The compute credits also totally help, by the way. Like that was a fun little bonus. But the reason I went for that is because I was also in a Discord group now where I can see what people are talking about, and that is a source of inspiration for me to go do my own personal experiments a bit more again. But I do kind of question everything that I see there. So one thing that did really dawn on me, and I still don't really know how to think about it, is it does seem that people really like to use ChatGPT to simulate training data for other systems. Like that I was actually like almost shocked to learn like that people wanted to do it that way. And the reason was because before I have seen that go wrong over and over and over again. But then again, we have not had generative systems that are as good as the stuff we've got now. So maybe it is actually kind of valid to maybe play around with that some more. Okay, forcing function, I'll figure out a way, but like that's something I will go ahead and explore then. And I'm pretty confident that I am going to be able to at least do something that's relatively interesting, something that could be a PyData talk or a tool that's useful to me personally. Like another thing that I'm doing right now is I'm scraping weather data because I want to predict the output of my solar panels. It's silly stuff like that, but it is like a problem in reality, right?
Yeah.
So if you're gonna go away with any lesson, try to broaden your horizon a bit, and you do that by exposing yourself to different problems, and also going down a rabbit hole and then back up again.
I love it. And as to the question, I can't speak to what that group would say. I don't work enough with synthetically generated data.
Same, but I want to now. Like I want to now. Yeah,
but I will.
Yeah,
I will quote. I've just inserted in the chat, and I'll put in the show notes a blog post by Cory Doctorow talking about someone called Sadowski, who coined a term called Habsburg AI. And essentially, they're reflecting on what will happen if we continually use the output of certain LLMs into other LLMs. So I'm going to read this.
Yeah.
Sadowski has a great term to describe the problem, Habsburg AI. Just as royal inbreeding produced a generation of supposed supermen who are incapable of reproducing themselves, so too will feeding a new model on the exhaust stream of the last one produce an ever-worsening gyre of tightly spiraling nonsense that eventually disappears up its own asshole. So people can read that. I promised Vincent I wouldn't swear on this this podcast, but it's a quotation.
No, and the only thing I'm smiling a bit. It really does sound like Cory.
Yeah, fantastic.
Like he likes to use those words, so that's always sometimes makes me giggle. But no, like I guess like another One thing I really do appreciate about that course that Hamal and friends made is it was nice to be able to cling on to a forcing function. Like my
Yes.
life is a bit busy now. Like I have a wife and kid, and like it's hectic and all that. But if I'm able to find a great forcing function that at least exposes myself to a problem, like usually that's the hard bit. It's not that like buying a book is easy. Actually reading it is the stuff that's hard. But if you can find a forcing function that really motivates you to go deep, like that, that might be the better game to play. Like find the forcing function. Um,
Um, let's jump in.
we're demoing soon, huh?
Yeah, do you want to tell
Okay.
us? Maybe you can tell us a bit about Calm Code first as
Oh,
well.
yeah. Yeah, so that can be the first demo actually, but I do have to share my screen.
Yes. And what if we could try to narrate it as well? Sometimes I leave these demos in the actual podcast, so if people may get something out of it, we can, or I can cut it as well.
Yeah, so it is definitely good to dictate what we're looking at. I'm sharing this in case people have not seen it, but
And
this
I'll
is the
share the
site
link in the
called
chat and show notes as well.
Yeah. So this is a very first short, it's very short first demo, but this is Calm Code. This is a project that I've maintained since COVID. It is just a learning resource of lots of tools that I think are very likable. It's me and another maintainer now. Like I've got like a partner in this now. Just a whole bunch of free content with tools that make your day to day a lot easier. We try to prefer the stuff that's very relevant, but not necessarily hypey. But this is the stuff that I do recommend. But one thing you can do now is you can actually go to calmcode.io/book and you will find this thing called data science fiction.
Awesome.
This is where I'm going to write the thing. You can give feedback and all that. Right now, there are three chapters. One chapter is about data at a hospital. The other one's about sending letters, and the other one's about waiting lines. And if you've seen my talks before, these are basically the anecdotes that you might expect that would go into one of my talks. And the goal is to have like 50 of these. These are all kind of like short essays, similar to how the rework people do it. Yeah, and this is like I guess it's like the first demo is now also done. Data science fiction. If people want to go ahead and read it, this is where you can find it. I am gonna go about writing this somewhat slowly. It's chugging along nicely. I don't want to haste this thing, but when there's new chapters out, it'll be in the emails. If you follow me, I'll talk about new chapters. So if this sounds interesting to folks, do check out data science fiction over at Calm Code, calmcode.io/book. Okay, and the speech on that one, because now I want to talk about actual code. And the first thing I want to talk about, and this is like solving a problem that I've got on my own. So if people saw my keynote, they might have seen this project of mine called arXiv front page. This is a GitHub repository that does a little bit of Git scraping. So there are GitHub actions in this thing. And basically what I do is every day I download the new articles from arXiv, and then I have a bunch of classifiers. And if the classifier detects a topic that I'm interested in, so I'm interested in reading articles about maybe active learning, or another one about new data sets that appear, etc. Then another part of the workflow gets triggered, and the GitHub pages will update. That's kind of the way that this system works. So you can go to GitHub pages. The whole ML ops thing, by the way, is just GitHub actions. And I have a section on new data sets that you can just go ahead and look at. The system works in such a way that I do sentence classification. So if a topic is detected in a sentence, that's kind of like the easiest way to sort of bootstrap this. That also gets highlighted with a probability value, But this was sort of my way to expose myself to interesting ideas on arXiv. When a new paper comes around with a topic that I'm interested in, it's not a perfect classifier, but this does kind of work. And what I can also do is I can also label some extra data. If I see like a line that I think is misclassified, I can go back to my labeling tool and actually sort of go ahead and fix it. But it did start to dawn on me that even though this is a cool way to expose yourself to new ideas, it does only expose yourself to papers that are being written now. And I maybe want to be able to find stuff that's a bit older. So I was kind of thinking like, okay, this kind of works, but maybe I should do something else. And that is sort of in this little demo over here. So just to clarify a few things how this works, what I've done is I've went to Kaggle, And on Kaggle, I found the big archive dump. So these are all the abstracts from arXiv, I think from the start. I could be wrong. I took the computer science ones, and I think I've got like 600K abstracts from arXiv with titles. And what I did is I went ahead and I embedded them. So I've got sentence transformers. I took the Matrushka embeddings. Those are relatively new, but I have a LansDB running locally. I didn't even build an index. This is all happening like brute force. But what I can now do is I can come up with some sort of a query. I can put that inside of, I can embed that, right? That's the first step. And then maybe I can build myself a good little search engine and find interesting articles that way. And this is something I did learn from that Hamal course. Like, because we're doing embedded search, we can actually do a little bit of prompting. So I might be able, if let's say I'm interested in label quality, so I could write a prompt like this: data set has bad, has new keyboard bad labels in it. So I have a little search box over here, and I'm just typing this data set has bad labels in it, and then I can go ahead and hit search. And again, I'm brute forcing, so this does take a while. But then some results come back. So if just the query, this data set has bad labels in it, one of the articles that I see here is exploring large-scale public medical image data sets. So okay, this does kind of fit, right? But because I'm dealing with neural search, I can actually make this prompt a whole lot larger. Like, it's not a search term that I can use. I can actually look for vibes a bit more. So I could maybe add something like label quality is important. Bad labels have consequences on downstream tasks. Like these are things I can add, right? And again, I'm doing brute force, so this takes a small while. But one thing that I did, again, sort of, I'm exposing myself to neural search a bit more. One thing I did pick up from Hamal's course is like, maybe we should celebrate prompting a bit more. Normal search also has its place, but I can really come up with a pretty long query. And because I'm searching for vibes a bit more here, hey, yeah, maybe the search bar is going to become a search box now. Like that's I think a pretty cool observation. But at the same time, it's also not enough. Because if I look at the examples that I get here, they are kind of in the domain of what I'm looking for. But this is the point where I also took a step back and I noticed that it's actually kind of hard to come up with a great prompt because I don't know what's in this data set. So I also don't necessarily know what jargon I should put in this prompt in order for it to like do proper work, right? There's still a challenge here. And I'm not intent on learning all the jargon up front. I just want to find the thing. And this is where it helps to have worked at Explosion before. Like before I was working on this thing called Prodigy, it was like a labeling tool. And this is one of those moments where I do kind of go like, yeah, this is a great starting point. But at this point, I just want to go ahead and label. Because if I look at this example, this really looks like something I'm interested in. I want to go ahead and hit positive match on that. And then I can kind of maybe scroll down, look for something that I'm not interested in. Oh, and identifying mislabeled instances and classification data sets. Good grief, that is so what I'm after, right? Maybe scroll down a bit. Mitigation on the state of German text summarization. Okay, yeah, that's something I'm just totally not interested in. So again, this is kind of a UI thing, right? Because it's I'm using the fact that sometimes it's easier to write a prompt and sometimes it's much easier to say yes on that, no on that.
So we do have a question in the chat as to why did you decide to not use BM25 or some other semantic search algorithm?
So the BM25, is that the token-based stuff?
So it's a ranking function that
oh right. I mean,
it ranks a set of documents based on the query, I think.
Right. Well, so the thing is, I am doing something else instead. But one thing to keep in mind, right? I have a kid, I have a wife, I have a job, and lots of responsibilities. I might have a few hours in the week to work on this sort of thing, which also means that I try to consciously work on sprints that are relatively simple. And there are definitely things that I could do to improve this. It's just that at this point in time, I hope you imagine that the UI was the more interesting thing to me.
Yeah.
So it wasn't so much throwing more tensors at it or throwing fancier like cost functions. I can definitely still do all of that later. But the main observation at this point is that I'm searching in a session and not in a search query.
Yep, right.
And I think that's the more interesting thing, because I'm using the fact that for me as a human, it's much easier to also do a little bit of labeling. And I'm assuming this is sort of a longer term search. I'm looking for rare things here. And in that case, it helps if there's a bit of interaction.
Absolutely.
The way this works internally, though, and like I am doing a bit of re-ranking, but the way that this works, I think I hit search when yeah, because these are here. So the way this works internally is I'm retrieving, I think, like 500 or 1,000 examples from LansDB. And then those things have to be sorted, but I'm actually using scikit-learn for that. So scikit-learn, as it turns out, and this is a semi-supervised learning, and then in scikit-learn. So scikit-learn, it turns out, has a semi-supervised learning module. And it's a bit of a hidden module because it's not necessarily the use case most people have. But the way it kind of works is, imagine, if you will, I've got this, I have an image in front of me right here, and there are two circles. One scattered circle in the middle, one scattered circle on the outset. And there's like one label in each circle, and the algorithm has to figure out how to classify the rest of the data. If this were a classification algorithm, the way it would work is there would probably be like some separating line between the two labels, but it wouldn't use the underlying structure of the circles. And that's kind of the point of what people like to call unsupervised machine learning. So the idea is, yeah, we are going to do classification, but we are going to focus on the underlying structure and or clusters of the data to propagate the label forward, kind of like a Markov chain, if you will. So you can imagine there's like a cluster. We're going to sort of connect all the nearest neighbors together inside of, and because the clusters are so well defined, there's never going to be an arc from one cluster to the next. And that is going to help propagate the label within this data set, so to say. Oh, and what's super cool about that? Well, that might be exactly what I need here. We have embeddings. They are going to form clusters. And if I give a few positive labels, then I want to see, then I've given a very strong signal, like find me more like that, right? And that's how this works for now. I have, there's still things I want to maybe improve upon it, but there's a few things I want to highlight here that I think are very useful. One, I am definitely pursuing, like the UI might be more important than the ML. At the same time, I am trying to expose myself to a field that's relatively new to me. Like I have done embedding stuff before, but I'm also exposing myself to prompting a bit more in doing this. And not prompting to an LLM, but prompting for like neural search. And I do think something about that is interesting. And it's going to help me learn like an aspect or two of a new field. But also three, this is a forcing function. Like I'm forcing myself to expose myself to something because this is a problem I actually have. I want to read more interesting articles. And Twitter doesn't really provide that to me anymore. Like 5 years ago, it was better at that than these days. But I don't really care about the machine learning under the hood. I also really just care about solving this problem. So that means I can also explore all sorts of other avenues that aren't just throwing more tensors at it.
That's really cool, Vincent. And thank you for sharing. I mean, it's a really nice kind of foray into things that interest you, but LLMs as well, and thinking about the data that's generated, then creating a UI where you can label things yourself, then doing a bit of semi-supervised, like it's kind of reaching for things when they become necessary based upon the problem, which I really appreciate you for. I do.
And also, I
was just going to ask: is this on GitHub or something, or can people use some of the code to build something themselves? Or
so soon? What I kind of want to do now is I want to generalize this somewhat. So I think the best thing I can do right now is make it such that this is easy to reproduce for other people. I think that arXiv is like general enough that more than just me will be interested in this. And then I can kind of turn this more into a competition. So I want to host this on Hugging Face with the idea that, hey, other people can now try out all sorts of other embeddings and all sorts of maybe other indexing techniques. And like, I need to write the right abstractions for it. But it's just a little Flask app and people can just always shoehorn a Python function in. But I think that's going to be like, it's the idea has been proven to me enough that it would help to maybe do this in public if I want to learn more from it. Some people, like I've previewed this before on my YouTube channel. People have come to me personally saying like, hey, I would love to help out. I'm going to Taylor Swift concert soon as well. So the next 2 weeks are like insanely hectic. After that, it is my goal to sort of put this live a bit more so we can so everyone can sort of have their own little playtime with it.
Awesome.
Because that is way more scalable than me trying out every single embedding at this point.
Well, do follow Vincent on Twitter and on LinkedIn, and I'll put those links in the show notes, so you can find out when he releases this stuff. Vincent, I do have one last question, and maybe stop sharing your screen now.
Oh, unless there is one more demo.
Oh, there is one more. Let's jump in. Yeah. Even better.
This is because I promised 3 demos. So those are the first 2.
You did.
So this is something that came out of the live stream that I do on behalf of my employer, probabl. And I'm not going to do the live coding because I do think that we don't have the most time for it. But I do want to maybe also paint a bit of a picture in terms of what some of the stuff I'm exploring at my employer. So what we're looking at here is a Jupyter notebook, nothing super fancy, and we're looking at the Titanic data set. There is going to be a chapter about this data set in Data Science Fiction, by the way, because there's something very insane about this data set once you go deep. But
is it even a real data set? I've never found any documentation to suggest that it actually comes from the Titanic.
Oh my, the rabbit hole really goes deep on that one.
Okay,
also,
no spoilers. Kaggle is the first place where I'd been able to trace it back to. So
Kaggle and like a generation of O'Reilly books use this data set. We're going to ignore like some of the interesting bits for now in favor of what do people typically do when they model this.
Well,
and this is a little bit
depending
more
on
in
the
the
question
domain
is, you can do a majority class classifier to begin with, as a baseline, which gives you 65% accuracy or something.
Yeah, and that's totally fine. Like you can basically do an average here, like who survived, yes, no. It's a binary classification. Doing a dummy classifier, very good practice. All that's well and good.
Biological sex is a really good predictor as well. In this case.
Oh, and passenger class. You know, you can make do with simpler models. But the reason I think this data set is interesting, sort of from a tooling perspective. So this is the thing we want to predict, and we want to use all of these separate columns to go in. So we've got this string column that says male or female. We have this integer column that gives you the passenger class. So that's 1, 2, or 3.
And we want to predict survived or not.
Yeah, we want to predict survived or not, but also we have to do some one-hot encoding on some of these things. Like there are steps involved in terms of pre-processing to get this data ready for prediction. Most machine learning algorithms cannot deal with a string column. You have to turn that into something numeric at some point.
Do you remember when we used to use get dummies?
Yeah. I have a video on the probabl YouTube channel on why that's a very, very terrible idea in production, in case you're interested. But yes, people used to do this with get dummies. There was a pandas function that would do the get dummies thing. In general, please use the one-hot encoder instead, because the one-hot encoder will remember which classes were seen during training, and then if it doesn't appear during fitting, like let's say pandas get dummies doesn't care about there's a new class at prediction time. Oh, we're going to one-hot encode that anyway and just see what happens. And sizes mess up and etc. One-hot encoder will give you a proper error. But again, from a tooling perspective, there are some columns we can just pass to the algorithm just fine. So we've got age. That's a numeric value. We've got the fair. And, there's a couple of columns we can just pass in. That's fine. But there's a couple of other columns where we have the passenger class and the sex. And that has to be one-hot encoded. And that's not even mentioning like the name of the passenger. Like if you really wanted to do something with machine learning on that, those are very long strings. So you would have to maybe make bigrams or like bag of words things with them. But you have to encode this in a different way as well. And if you want to get started with a fairly basic algorithm in scikit-learn, this is the way you still have to do it. The pipeline API is amazing because you can really write proper elaborate pipelines with it. But I was looking at this, sort of wondering, imagine you're a recent graduate and you've got a very strong stats background. There's like a function in here. There's like some objects in there. Like you actually do have to know a bit of Python in order to do some modeling here. Now, the amount of Python you have to know is actually not, the worst thing out there, but I was wondering, like, is there an opportunity to rethink a little bit of stuff here? And what I'm about to show you is not what I think is the best practice out there, but it is, I think, an interesting idea that I'm at least exploring. So I'm wondering, like, can we rethink the way we declare the pipeline? I still like the idea of the scikit-learn pipeline, but I'm just wondering, can we do something clever when it comes to declaring this guy. So one thing that I'm exploring right now, like, and you can see over here, by the way, like this is the representation that scikit-learn sort of gives you of the pipeline. But I've been working on this library called Playtime. So you can pip install Scikit-Playtime right now. And what I'm saying is, what if we just say there's just some features and we just have this one function and we have some features over here. These are just the columns to grab. Then there's some stuff to one-hot encode. And then there's there's another feature that we just want to do the bag of words thing for. And maybe if we just have like functions that we can have these plus operators and we put them together, then maybe that can just generate the same pipeline for us.
So those pluses make, like, I kind of want pipes there or something.
Well, this is a feature union. So the way this works internally is when you see a plus here, a make union is actually sort of happening under the hood. But you are pointing to something that's actually equally interesting. Like, what if we multiply here instead? Oh, what we could do then is we could say, well, multiply everything here with everything here. Oh, and hang on. What if we have like a bar, like a pipe? Oh, well, then I can actually pass that to whatever scikit-learn thing after. That's also something I could just kind of build in.
Cool.
Huh. Okay, so I'm not sure yet if this is a great idea, but I am tickled a bit here because I do think there's something about changing the notation that also changes the way you think about it. And that I think is also, again, UI. This is kind of an interesting thing. You're definitely not going to be as elaborate as the normal scikit-learn pipeline is going to allow you to be, by the way. Like, this is not something that's going to replace the pipeline anytime soon. And also, I have some colleagues and some collaborators on GitHub that are also doing something different in the same realm for the Scrub project. Scrub is also this thing under the probabl umbrella. There are also other ways you could rethink these pipelines. But I do want to maybe give a glimmer sort of to tell people, like, this is the level of rethinking that you can also do. Like, some of the stuff is also like, do I like the code that I'm writing? And if not, there's also a UI there, which I think is good to maybe think about. Now, to give like a final preview of like, Vincent, how on earth did you end up doing this? The future of this is going to be time series. So one thing that I'm particularly interested in is one thing you can also do here is there is also a seasonal operator. Like, you can pass that a date column. And then it can do like seasonal features during the year. So you can have like hills in January and stuff. But if you imagine that I've got like a seasonal pattern feature here, if I were to multiply that by something that's one-hot encoded for maybe like the day of the week, oh, then I can have a seasonal pattern for every day of the week. And in retail, that's super useful.
Yeah.
Because the seasonal effect that you're going to have in the weekend is usually really different than you're going to have during the week. And why stop there? Because we might also have a different seasonal feature per store. And this is this particular kind of time series, to me, feels a lot more easy to declare this way than with the normal scikit-learn pipeline. And again, what I hope that people get from this is kind of oh yeah, this is also UI and a bit of exposing yourself to a different problem and then taking a step back and rethinking and sort of iterating and stuff. But I'm not thinking about tensors. And I'm hoping more people will join me in this.
I love it. And I really think it's lovely to bring full circle this idea of rethinking what we're doing, but in terms of the tools we're using and the tools we're building as well.
Yeah. And again, you can also go too far in rethinking. Like, if you keep rethinking but not build anything, that's also like a rabbit hole, right? Like, don't jump into that. But yeah, like, hopefully this is enough for people to sort of think about. And again, like, most of the tools we want to have haven't been built yet, right? That's also a thing to remember. So yeah, but enough stuff to do, I would say.
So I'd like to wrap up. We've talked a lot about kind of how to rethink the space we work in and certain failure modes. I suppose I'd love to know just what you love about what you do, what we do, and what you're excited about in the coming months and years in the space.
So, I mean, one thing, this is really particular to the current employer. Like, I work at a company called probabl, and, there's a couple of scikit-learn maintainers hang out there. And part of my job is also to be kind of like a dev advocate, but in this particular case, I really get to dive into some of the scikit-learn code bases and really expose myself to like decades of proper computer science. And there are some real gems in that. And part of my job is also to, share some of those ideas and make sure that they're properly archived and not forgotten. So personally, that is something I'm really looking forward to. My role is a little bit different because I don't just do DevRel stuff. Usually what I do is I hide in a cave for 2 weeks, make sure that I've got like a month of content, and then I hang out with another team and join them for a sprint. That's kind of more my role at this point for the company. But I do enjoy being able to do that with this with a scikit-learn ecosystem. It's a really weird library in the sense that it's kind of rare that for a decade I have this feeling of, huh, scikit-learn can do that, and like I'm past a decade now and I still have that feeling. So that's on the short term. That's what I'm really looking forward to. But also like combined with that, as much as I really like the employer, I think my life is more interesting by also doing stuff besides just working for a employer. So I also have my personal projects that I'm really looking forward to. One thing that, again, the Hamal course did is it did motivate me to make a new version of Bulk. Google it. If you go to the repo, people will be able to find what it does. Bulk is going to have like a really cool upgrade, so I'm also looking forward to do that. Comcode now has a collaborator, really eager to sort of do stuff like that. I have the data science fiction book, and I have stuff like this for the probabl live stream. And I think that something about that chaotic mix, yeah, that's super cool. Like that really blends well with the family situation as well. So that honestly, I'm just looking forward to continuing riding this wave. That's the main thing.
We have a lot in common, my friend.
Yeah, it's like that feeling is
in the chaos
best.
of
Like,
it all.
yeah, like that productive chaos. That works really well for me right now.
Awesome. And I've put links to probabl, to your Twitter, to Calm Code in the show notes and in the chat as well. I am interested. If there's anything else you'd encourage people to do, or what a call to action for listeners who want to find out more and do more.
So there's like two things I guess on the short term. I mean, PyData Eindhoven is happening next week, and I will be speaking there. Yeah, you're gonna see a very similar demo maybe, but I'm gonna talk about the title.
You saw
of
it
the
here
talk
first, people, on Vanishing Gradients.
Yes. No, so the title of the talk is Scikit-learn can do that, because that's the feeling I want to describe, and I'm gonna go a little bit in depth into some of the details that like there's one trick that I think more people should just know for their day to day. And there's this one other thing that scikit-learn does that's hidden that I want to talk about. So that if that sounds interesting, check out.
Come on, man. I can't make it to Eindhoven next week.
The video's going to be on PyData video is going to be online.
Okay,
so like,
great. I'll wait and bite my tongue then.
Yeah, but the PyDatas are really fun, and I've had a small role in like kickstarting PyData in the Netherlands. So it's really like for me, it's also really cool to hang out there just to see what like the new generation of PyData people are doing. So it's like pretty epic. Another thing that might also be good, I promised Michael I would mention it. So Michael from Talk Python, that's another very
Michael
popular.
Kennedy. Everyone should check out Talk. I mean, if you're listening to this, you probably know of Talk Python to me, but if you don't, Michael's a legend.
Yeah, and Michael's really cool, and also the Python Bytes he does with Brian Hawkins, similar story, like very just cool, relatively calm, likable podcast. I have collaborated with him. So like the final thing I did as I was leaving Explosion Spacey and joining Scikit-learn probabl was work on a course. You can check it out. No pressure. If you do end up buying it, it's relatively cheap, but it does also help support the Talk Python podcast, which is also something I really enjoyed about working with Michael there. So like that's a call to action I can come up with. I mean, other than that, what I would also maybe, if I can give like the best call to action, I would love for people to blog more. So if you have like a feeling of, hey, today I learned something, like just write that paragraph down and like make sure that people can find it. I am again like Twitter still has some Twitter vibes to it, but it's not the same in terms of like cool information just sort of floats up. But I think one thing we could do more is maybe have like good blogs with RSS feeds. And I've noticed a lot of more people are doing it more actively. But if I can motivate you to do something similar, I do miss. Like I would wish more people had like really solid data science blogs of like, hey, here's a cool trick, here's a weird little scikit-learn thing. Like probabl employs someone to just focus on the scikit-learn docs. That's a podcast for another episode because there's lots of stories there. But even employing someone to sort of try to share all the lessons out there is not enough. Like if the community could help out by just sharing lessons that they've learned individually, I think that will also just be really cool for everyone.
I totally agree. And also, I don't know who out there thinks this. I've had challenges thinking this, that, to write a blog post, I need to write something very meaty and substantial. Whereas you can just write a quick little thing of something you learned as well. And actually, Vincent, when you and I hung out in person a couple of months ago in Amsterdam, we talked about how Simon Willison is so prolific.
Yeah.
And I spoke, and check out Simon Willison, his LLM client project, his dataset project, also co-creator of Django, among other things. So that's another
minor
story.
Minor thing. Just he casually.
I asked him how he did so much, and he said there are two things. One, he has his TIL blog, his Today I Learnt blog, where he's just like, can just put something he learned, and it doesn't need to be new, novel. The other
brain
thing,
fart, dump it. Yeah,
exactly. The other thing which you spoke to earlier is he was like, I often will only engage in a project if I know it'll be a small project and take a short amount of time, and I can time box it. Then I can write it up quickly. So, these types of tools are useful for structured work as well.
Another fun one. Okay, I'm gonna make another pitch. I wrote a library a while ago called Doubt Lab, and the number one way people can
How do you spell
help
that?
me on that, doubt and then lab. The library is all about doubting labels and giving you like a little lab to sort of do that. There are really just a couple of functions with tricks like comparing two model outputs or like finding outliers. And like the point is that I want to find reasons to doubt a label to help you prioritize which labels to check first. Like that's sort of the goal of the library. And what I think is the main contribution anyone can do for that library is to use some of the tricks to actually find bad labels in actual public data sets. And like the tiniest blog post of that will be the best contribution you can make to the docs. But you don't have to do it on my blog. You can also do it on your own. But like if you can find a data set that is widely used and you can find some label errors in it, usually that's a fun story. Another thing you can also do, that's how I got started with like talking at conferences. There tend to be a couple of these data sets about video games. Can you data mine your way into an edge? Is a fun thing to maybe do. Like they pulled down the API, but something I did like when I got started back in the day, World of Warcraft actually had their auction API public. So one of the first things, like I wanted to learn Apache Spark. So I needed to have a big data set. So I downloaded gigabytes of World of Warcraft auction house data in order to do economic analysis between auction house servers. Like what influences the price of a potion, so to say, like stuff like silly stuff like that. Do not underestimate how fun those conference talks are or how fun those blog posts are. Or like another thing I did is the Lego minifigures. So those are collectibles, right? If you buy 16 packs, what's the probability you get a full set?
How many are there?
So there's six. I think there's 16 in the collection. But there's an interesting like math like simulation exercise here. Like how many packs do I have to buy in order to guarantee that I've got 5 full sets?
Yeah, I mean you do the one minus trick, right? And then you.
But then but now you say I want to buy. How many sets do I have when I buy 200? That like it gets subtle, but you need like a different math formula for that. That I think is intractable, but you can simulate it very easily. And then you can actually decide for yourself, does it make sense to invest in Lego minifigures when it comes to like selling it 10 years later down the line on eBay? Because it is a collectible.
Yep.
Silly, tangible things like that do really go a long way. And also like a pro tip for any blog post and like conference talk in general, back when I was reviewing conference talks for PyData, if the talk has to prove to me 2 things, if it's enjoyable, like I think it's interesting, and will I learn something? Like those are if it does those 2 things, you're good. Because most talks, most talks and blog posts don't do both at the same time. But even if I learn only a little, and even if I think it's only a little bit interesting, that's sufficient for me to want to read it.
Yeah, totally.
And come up with a good title. Sure, but still, like a lot of this stuff, like it is time. I don't want to suggest it's super easy. But it might be easier than you might think. And you might also want to appreciate how crucial it is to keep good ideas from, like, if we want good ideas to come around and keep happening, we have to share them. right? Like that is something that needs to happen. So again, I implore you, please do interesting stuff and blog about it or talk about it or something like that. Like the world definitely could use more of that. And feel free to focus on stuff that you are like super nerdy interested in. Those are usually the cool things to read.
I encourage you all to do the same. Normally, if someone came on the podcast and said the world doesn't have enough content, I'd say, get out of here. But in this case, I mean, we are talking significantly about like writing things and communicating things that increase signal to noise ratio, which is
Yeah,
one of the most important jobs we can do in the noise currently.
yeah, and like don't be the influencer, but be the nerd. Like be the person who's celebrating that you're super excited about this one little weird ass detail.
Yep.
Like I was talking to a guy the other day. You know, knitting machines, how they can sort of knit a figure into. Okay, can you come up with an algorithm that can do that with the least amount of yarn?
Cool.
That's actually like a super hard problem.
It's a great question.
And super interesting. Yeah, and because you also want it to look pretty, and there's all sorts of interesting constraints there, right? But like, again, I encourage the person to definitely blog about it because that stuff is super duper interesting. I wish more people would do it.
And for anyone still listening, Vincent has just given us 10 ideas of questions to ask and figure out and write about as well.
Yeah, and figure out what makes you tick and go for it. Definitely.
I'd like to thank you once again. I'd like to thank everyone who's joined, and there are 25 people who are still here, and have been with us for over an hour and a half. Well, it's getting up to 2 hours, which is super awesome. Please do check out Calm Code, check out Probabl, check out Vincent on LinkedIn and Twitter. Someone has mentioned they're excited for the PyData Eindhoven event as well. Thank you all for sticking around, but most of all, Vincent, I always love chatting with you. I always learn a lot, and I'm always entertained as well. But thank you most of all for your wisdom and doing the work you do and bringing back all the battle stories also.
My pleasure. Thanks for doing the podcast. There's not a lot of solid data science podcasts, and this is one of them.
I appreciate it. So thanks, everyone. And oh yeah, once again, like and subscribe, of course, if you're still around. And what I'm also going to do, we have these live streams quite often now, so I'm going to put a link. Reminder, it was on my checklist to do at the start. I'm going to put a link to the Luma calendar with our events on it in the chat as well. We've got a couple coming up. And actually, you mentioned Hamel and Dan's course. I've got one in a couple of weeks with them about what they learned teaching LLMs to thousands of people.
Like one thing, it's kind of. Do you remember NormConf?
Yeah, I do.
Same vibe. Like the thing that they did had like a NormConf vibe to it.
Yeah,
which
yeah.
I did not expect in LLM land, but it did kind of. It was a unexpected heap at some point. Everyone just kind of jumped in on it, and something about that also made it a really cool event.
Absolutely. And of course the credits, but also to your point earlier, and the point of blogging and communication and having searchable communication, these types of things, the Discord for this course is a phenomenal resource.
Yeah.
Loads of stuff about.
Yeah. Not a huge fan of Discord in the way the app works, but I'm still eager to hang out there. Definitely.
Yeah. I'm not a huge fan of many apps in the way the apps work. So
yeah, notifications are crazy on that thing. You really have to turn a lot of stuff off. But
exactly.
but I did learn a bunch of stuff there, so that's definitely cool. Yeah, looking forward to that podcast. Sounds like fun.
Likewise. All right, everyone. Thanks once again, and we'll see you in the next episode. And